I am the virtual teacher at Egnatia Career College. Today we'll teach cornices, windows and doors, exterior wall coverings, decks, finishing site work. This is video number 6. Cornices. After completing this unit, you will be able to perform the following tasks. Describe the cornice construction shown on a set of drawings. List the sizes of the individual parts of the cornice shown on a set of drawings. Describe the provisions for attic or roof ventilation as shown on a set of drawings. Types of cornices. The cornice is the construction at the place where the edge of the roof joins the sidewall of the building. On hip roofs, the cornice is similar on all 4 sides of the building. On gable and shed roofs, the cornice follows the pitch of the end, rake, rafters. The cornice on the ends of a gable or shed roof is sometimes called simply the rake. The 3 main types of cornice are the box cornice, the open cornice, and the close cornice. Box cornice. The box cornice boxes the rafter tails. This type of cornice includes a fascia and soffit. The fascia covers the ends of the rafter tails. The soffit covers the underside of the rafter tails. There are 3 types of box cornices. These types vary in the way the soffit is applied. Sloping box cornice. In the sloping box cornice, the soffit is nailed directly to the bottom edge of the rafter tails. This causes the soffit to have the same slope or pitch as the rafter. Narrow box cornice. In the narrow box cornice, the rafter tails are cut level. The soffit is nailed to this level cut surface. Wide box cornice. In a wide box cornice, the overhang is too wide for a level cut on the rafter tails to hold the full width of the soffit. In conventional wood framing, lookouts are installed between the rafter ends and the sidewall. The lookouts provide a nailing surface for the soffit. For a metal soffit, special metal channels fasten to the sidewall, and the back of the fascia hold the soffit. Open cornice. In an open cornice, the underside of the rafters is left exposed. Blocking is installed between the rafters and above the wall plate to seal the cornice from the weather. An open cornice may or may not include a fascia. Closed cornice. In a closed cornice, the rafters do not overhang beyond the sidewall. The interior may be sealed by the sheathing and siding or by a fascia. In either case, there must be some provision for ventilation. Cornice returns. Any type of construction described for cornices can be used for the rake. When a sloping cornice is used, the fascia and soffit follow the line of the roof up the rake. When a level box cornice is used, a cornice return is necessary. This is the construction that joins the level soffit and fascia of the eave with the sloping rake. The style of cornice return is shown on the building elevations. Although good architectural drafting practice requires details of all special construction, many architects do not include details of cornice returns. The carpenter is expected to know how to achieve the desired results. These 2 figures show the construction of 2 popular types of cornice returns. Ventilation. The cornice must allow for ventilation of the attic or roof. Attic or roof ventilation is necessary in both hot and cold weather. Without ventilation, the air in the attic becomes stagnant because it is trapped and unable to circulate. In hot weather, this stagnant air builds up heat and makes the house warmer. Hot, stagnant air can hold a large amount of moisture. When this moisture-laden air comes in contact with the cooler roof, the moisture condenses. The condensation can reduce the effectiveness of the insulation. Condensation can also cause the wood in the attic to rot. In some areas, especially where houses do not have basements, it is common to locate furnaces and water heaters in the attic. Combustion equipment, such as gas-fired furnaces and water heaters, should not be located in a conditioned attic unless it is in a separate space that is sealed off from the rest of the conditioned spaces of the house. A conditioned attic would be one in which the insulation is placed against the roof instead of the floor. If backdrafting occurs, carbon monoxide can escape into the surrounding space. In addition to the danger posed by carbon monoxide, backdrafting can cause water vapor from burning fuel to remain in the attic and increase the chances of condensation forming in the attic. Attic or roof ventilation also helps prevent ice buildup in cold climates. Without ventilation, the heat from the building melts the snow that falls on the roof. As the melted snow reaches the overhang of the roof, it refreezes. Eventually, an ice dam may build up. The ice dam can back up newly melted snow, causing it to seep under the shingles. Ventilation is created by allowing cool air to enter through the cornice and exit at the ridge or through special ventilators. A section view of the sidewalls or a special roof and cornice detail shows the construction of the cornice, including any ventilators. Using I-joists for rafters allows for greater rafter lengths and conserves natural lumber resources. But such framing requires construction details that are not normally required with solid lumber. This figure shows the necessary provisions for roof framing with TJIs. Notice that many of these details include a V-cut to allow airflow. The heated air can be allowed to exit in one of three ways. Some buildings have a ventilated metal ridge cap. This may be shown on the building elevations or on a separate detail. When a ventilated ridge is used, an opening is left in the roof decking at the ridge. Metal roof ventilators can be installed in the roof. Ventilators can be installed in the gables. Metal roof ventilators and gable ventilators are usually shown on the building elevations only. Windows and doors. After completing this unit, you will be able to perform the following tasks. Interpret information shown on window and door details. Find information in window and door manufacturers' catalogs and online listings. Window construction. Most windows are supplied by manufacturers as a completely assembled unit. However, the carpenters who install windows often have to refer to window details for information. Some special installations require knowledge of the construction of the window unit. Also, when a special window is required, the carpenter may build parts of it on the construction site. Wood windows. The major types of windows are briefly discussed in Unit 19. All these windows include a frame and sash. The sash is the glass and the wood, or metal, that holds the glass. The sash is made of rails, horizontal parts, and stiles, vertical parts. The sash may also include muntins. Muntins are small strips that divide the glass into smaller panes. The glass is sometimes called the light. The window frame is made of the side jambs, the head jamb, and the sill. Stop molding is applied to the inside of the jambs to hold the sash in place. Factory-built windows also come with the exterior casing installed. The casing is the molding that goes against the wall around the frame. The interior casing and the apron, if one is included, are applied after the window is installed. Metal windows. Many buildings have vinyl or metal windows. Improvements in the design of metal windows have made them competitive with wood windows in both cost and energy efficiency. The most important of these design improvements has been the development of thermal break windows. Thermal break windows use a combination of air spaces and materials that do not conduct heat easily to separate the exterior from the interior. The basic parts of a metal or vinyl window are similar to those of a wood window. The sash consists of a stile, rails, and glazing. The frame is made up of side jambs, a head jamb, and a sill. However, the trim casing is not included as part of the window. Often the window frame itself is the only trim used on the exterior. The frame includes a nailing fin for attaching the window to the building framing. Window details. All windows include the parts discussed so far. However, to show the smaller parts, which vary from one window style to another, architects and manufacturers use detail drawings. The most common type of window detail is a section. All the parts can be shown in section views of the head, sill, and one side jamb. These sections also usually show the wall framing around the window. Some of the parts that can be found on window sections are defined here. Find each of the parts on the sections and illustrations in this figure. This figure shows section views of an awning window. Fenestration is all of the openings in the building that are intended to allow air, daylight, people, animals, and vehicles to enter and exit the building. This is primarily windows, doors, and skylights. Even the best windows and doors tend to have poorer thermal insulating qualities than the surrounding wall. By eliminating all windows and doors, the heating and cooling load for the building could be greatly reduced. However, it would not be a pleasant home in which to live. Green home designers pay particular attention to the sizes and locations of all fenestration. The thermal quality of a window is also greatly affected by its glazing. By using glass with low energy transmission properties, low-E glass, and filling the space between the layers of glass with inert gas, its heat transmission and solar properties can be improved. Weather stripping is used on windows that open and close. It forms a weathertight seal around the sash. The transom bar is the horizontal part of a window frame that separates the upper and lower sash when one is a fixed sash. Meetings rails or check rails are the rails that meet in the middle of a double-hung window. Insulating glass is a double or triple layer of glass, creating a space between the layers. The space is filled with inert gas such as argon and acts as an insulator. Extension jambs are fastened to standard jambs when the window is installed in a thicker than normal wall. A mullion is a vertical section of the frame that separates side-by-side sash. If the mullion is formed by butting two windows together, it is called a narrow mullion. If the mullion is built around a stud or other structural support, it is called a support mullion. Door construction. Doors include many of the same basic parts as windows. A door frame consists of side jambs and a head jamb with stop and casing. Exterior door frames also include a sill. Many doors are made of a framework with panels. The parts of panel doors are named similarly to the parts of a window. The vertical parts are stiles and the horizontal parts are rails. Doors with glass or louvers are variations of panel doors. The framework is made of rails and stiles, and the glass or louvers replace the panels. Several manufacturers make molded doors. The most common type of molded door is made of hardboard for interior doors or steel for exterior doors, which is manufactured in folds that contour the surface to look like panel doors. Hollow core doors consist of an internal frame with skin applied to each side. Exterior doors have insulation between the two outer steel skins. These insulated doors result in considerable heating and cooling savings. Door details. Door details are usually less complex than window details. Where security, fire alarm, electronic lock, or special systems must be run in door and window metal frames, the corresponding installers must familiarize themselves with the actual manufacturer details and coordinate their installation with the door and window installation schedule. Carpenters rarely make doors, so all that is needed are simple details of the door frame and its trim. Doors must insulate the conditioned space inside the home from the hot or cold weather outside and seal the opening against infiltration of air and water, sometimes in strong winds. If the door is glazed, that part of the door can be treated like a window and insulated with low-E glass and inert gas between the layers of glass. The rest of the door can be insulated by filling it with insulating material. To properly seal the opening requires a good weather seal on a good fitting door. If the weather seal is pinched or has gaps, air and water will enter at that point. If the door does not close evenly against the weather seal, that will cause leaks. The same principles apply to windows and skylights. Many doors are sold as pre-hung units. In these units, the frame is assembled, including the trim, and the door is hung in the frame. A section view of the jambs shows how the door is installed. For example, the door detailed in this figure is made with two-piece jambs. These split jambs are pulled apart, each side is then slid into the opening for installation. The stop can be either applied or integral. Applied stop is molding that is applied to the jambs with finish nails. Integral stop is milled as a part of the jamb when the jamb is manufactured. Reading catalogs. It is often necessary to find specific information about windows or doors in the manufacturer's catalog or on its website. Usually, the catalog has a table of contents and websites have a home page that lists the types of windows and doors available and illustrated. For each type of window or door, you will find some or all of the information listed below. A brief description of the window type and some of the features the manufacturer wants to highlight. A little advertising. Installation detail drawings. Sizes available. This information usually consists of drawings of the various sizes and arrangements, with dimensions for glass size, stud or rough opening, and unit dimensions. This figure shows typical window size information reprinted from a manufacturer's catalog. Additional information, such as optional equipment available. Each manufacturer uses its own design to show the information. It sometimes takes a minute of study to familiarize yourself with how the manufacturer's pages are designed. Also, each manufacturer may make slightly different sizes of stock windows. If the windows used in constructing a building are from a different manufacturer than the one the architect used to make the drawings, it may be necessary to find windows that are as close as possible to the sizes shown on the drawings. Of course, if the construction specifications call for a particular manufacturer, that specification must be followed unless a change is authorized by the architect or owner. Exterior wall coverings. After completing this unit, you will be able to perform the following tasks. Describe the exterior wall covering plan for all parts of a building. Explain how flashing, drip caps, and other devices are used to shed water. Describe the treatment to be used at corners and edges of the exterior wall covering. Wood siding. Wood is a popular siding material because it is available in a variety of patterns, it is easy to work with, and it is durable. Wood siding includes horizontal boards, vertical boards, shingles, and plywood. Boards can be cut into a variety of shapes for use as horizontal siding. These boards are nailed to the wall surface starting at the bottom and working toward the top. With lapped boards and beveled siding, a starting strip of wood furring is nailed to the bottom of the wall. This starting strip holds the bottom edge of the first piece of siding away from the wall. Each board covers the top edge of the one below. The amount of each board left exposed to the weather is called the exposure of the siding. Vertical siding patterns can be created by boards or plywood. These materials are applied directly to the wall with no special starting strips. However, where horizontal joints are necessary, Z-flashing should be applied. Shingles take longer to apply but make an excellent siding material. In place of a starting strip, the bottom course row of shingles is doubled. Fiber cement siding is made of Portland cement, ground sand, cellulose fiber, and additives mixed with water and formed into siding. Fiber cement siding will not rot and it is termite-proof. Fiber cement siding looks like wood siding. It comes in a smooth finish, a wood grain texture, and even a rough sawn look, and it is available in widths of 6, 7.5, 9.5, and 12 inches. Fiber cement siding is sometimes referred to as hardy plank, a popular brand of fiber cement siding. Hardy plank comes in standard 12-foot lengths, while other siding materials come in 16-foot lengths. The 4-foot difference is because fiber cement siding is much heavier than wood siding, and anything over 12 feet would be difficult for one person to handle. Although fiber cement siding looks like wood and it is installed in much the same way as wood, it is important to follow the manufacturer's installation instructions to maintain the warranty on the siding. Drip caps and flashing. It is important to prevent water from getting behind the siding, where it can cause dry rot and attract insects. Where a horizontal surface meets the siding, water is apt to collect. Flashing is used to prevent this water from running behind the siding. Aluminum, galvanized steel, and copper are the most common flashing materials. The flashing is nailed to the wall before the siding is applied. The lower edge of the flashing extends over the horizontal surface far enough to prevent the water from running behind the siding. Areas to be flashed are usually noted on building elevations, but the carpenter should be familiar with flashing practices and install flashing wherever water penetration might be a problem. The flashing is also usually shown on the detailed drawings. The heads of windows and doors may form a small horizontal surface. Wood drip cap molding can be used in these places to shed water. Drip caps are shown on details and elevations. Together with the roofing, the exterior wall finish is the home's first line of defense against water. There are many exterior finish materials available to the home builder, and most of them are capable of doing an excellent job of shedding water. None of them, however, will do a good job if not installed properly. Most water enters the home through the force of gravity. As it either drips off the roof or strikes the wall near the top, it flows downward, always seeking the path of least resistance. Sometimes that path of least resistance is through a gap in a drip cap over a door or window, or through a poorly fitted piece of flashing. The key to success is to install all wall covering materials, house wrap, flashing, siding, masonry veneer, paint, or whatever is called for with care and according to the manufacturer's instructions. Corner and edge treatment. Regardless of the kind of siding used, the edges must be covered to prevent water from soaking into the end grain or running behind the siding. Around windows, vents, doors, and other wall openings, the trim around the opening usually covers the end grain of the siding. In an inside corner, a strip of wood can be used to form a corner bead for the siding. Outside corners in plywood, hardboard sheets, or vertical boards are usually built with corner boards. Horizontal siding is butted against the corner boards. Shingles are trimmed to form their own outside corner, or they are butted against corner boards. The corner treatment to be used can usually be seen on the building elevations. If no corner treatment is shown on the elevations, look for a special detail of a typical corner. Metal and plastic siding. Several manufacturers produce aluminum, steel, and vinyl siding in trim. The most common type is made to look like horizontal beveled wood siding. A variety of trim pieces are available for any type of application. Stucco. Stucco is a plaster made with Portland cement. The wall sheathing is covered with waterproof building paper. Next, the lath, usually wire netting, is stapled to the wall. Finally, the stucco is troweled on a rough scratch coat first, then a brown coat to build up to the approximate thickness, and finally a finish coat. Outside corners and edges are formed with galvanized metal beads nailed to the wall before the scratch coat is applied. Masonry veneer. Masonry veneer is usually either brick or natural stone. It is called veneer because it is a thin layer of masonry over some kind of structural wall. The structure may be wood framing, metal framing, or concrete blocks. The masonry has to rest on a solid foundation. Normally, the building foundation is built with a 4-inch ledge to support the masonry veneer. This ledge can be seen in a typical wall section. Interesting patterns can be created by using half bricks and bricks in different positions. Some of the most common bond patterns, as they are called, are shown in this figure. If no pattern is indicated, the bricks are normally laid in a running bond. Above and below windows, above doors, and in other special areas, bricks may be laid in varying positions. If bricks are to be laid in any but the stretcher position, they will be shown on the detailed drawings. The details for openings in masonry walls will also indicate a lintel at the top of the opening. The lintel is usually angle iron. It carries the weight of the masonry above the opening. Decks. After completing this unit, you will be able to perform the following tasks. Explain how a deck is to be supported. Describe how a deck is to be anchored to the house. Locate the necessary information to build handrails on decks. Introduction. Wood decks are used to extend the living area of a house to the outdoors. A deck may be a single-level platform, or it may be a complex structure with several levels and shapes. However, nearly all wood decks are made of wood planks or synthetic planks made to simulate wood laid over joists or beams. The planks are laid with a small space between them, so rainwater does not collect on the deck. The same construction methods are used for decks and porches as for other parts of the house. The parts of deck construction that require special attention or that were not covered earlier in the text are discussed here. Support. The deck must be supported by stable earth. The support must also extend below the frost line in cold climates. The most common method of support is by concrete columns with metal post anchors. A typical metal post anchor is shown in this figure. Such anchors fasten posts to the concrete pier, while keeping them from contacting the concrete in order to prevent decay. Indeed, all wood used in the construction of a deck should be pressure treated with a chemical to prevent such decay. Note that deck detail 3/6 for the lake house includes a note that all wood is to be pressure treated. There are a number of products made from combinations of wood fibers and synthetic materials, plastics, that may be used for decks and other outdoor structures. These products, called composites, are not affected by weather, moisture, or termites. They can generally be worked with ordinary carpentry tools and fasteners. Of course, as with all products, you should read and follow the manufacturer's instructions for installation. Decks are usually included on the floor plans for the house. The floor plans show the overall dimensions of the decks and the locations of posts, piers, or other support. If the decks are complex, they may be shown on a separate plan or detail. On the lake house, the decks are shown on the floor framing plan. Typically, the posts or piers support a beam or girder, which in turn supports joists. The beam may be solid wood or built-up wood. The joists can be butted against or rested on top of the beam in any of the ways discussed for floor framing. Anchoring the deck. The most common ways of anchoring the deck to the building are shown in this figure. If the deck is at the same level as the house floor, the deck joists can be cantilevered from the floor joists. In this case, blocking is required between the joists. If the deck is secured with anchor bolts in a concrete foundation, the anchor bolts must be positioned when the foundation is poured. If the deck is to be added to an existing concrete wall, anchors made for this purpose can be inserted into drilled holes. There are many different types of anchors available, but only those rated for this use should be used to fasten the deck to the house. The anchor bolts or through bolts hold a joist header. The deck joists either rest on top of the header or butt against it. If the joists butt against the header, they are supported by joist hangers or a ledger strip. Decks and outdoor structures are parts of the home. In the spirit of designing and building a green home, the same principles that apply to the house should be applied to decks. Design on a 2-foot module, avoid unnecessary corners, angles, and curves, select materials that require a minimum of maintenance and do not involve unnecessary embodied energy, the energy required to manufacture and transport a product, and always observe best practices. Use quality workmanship. Although all deck framing should be built of pressure-treated lumber, it is still important to prevent water from collecting on top of the header. This can be done by cementing flashing into a kerf, i.e., saw cut, in the concrete wall or with caulking. Railings. Most decks have a railing because they are several feet from the ground. Although metal railings are available in ready-to-install form, the architectural style of most wood decks calls for a carpenter-built wood or composite railing. The simplest type of railing is made of uprights and 2 or 3 horizontal rails. The uprights are bolted to the deck frame, and the rails are bolted, screwed, or nailed to the uprights. The style of the railing and the hardware involved are usually indicated on a detailed drawing. Finishing site work. After completing this unit, you will be able to perform the following tasks. Describe retaining walls, planters, and other constructed landscape features shown on a set of drawings. Find the dimensions of paved areas. Identify new plantings and other finished landscaping shown on a site plan or landscape plan. Introduction. As the exterior of the building is being finished or soon after it is finished, the masons, carpenters, and landscapers begin the finished landscape work. Any constructed features, called site appurtenances, are completed first. Then trees and shrubs are planted. Finally, lawns are planted. Retaining walls. Retaining walls are used where sudden changes in elevation are required. The retaining wall retains or holds back the earth. Where the height of the retaining wall is several feet, the earth may put considerable stress on the wall. Therefore, it is important to build the wall according to the plans of the designer. A section through the wall usually is included to show the thickness of the wall, its foundation, and any reinforcing steel. For low retaining walls, the site plan may be the only drawing included. Introduction. Wood decks are used to extend the living area of a house to the outdoors. A deck may be a single-level platform, or it may be a complex structure with several levels and shapes. However, nearly all wood decks are made of wood planks or synthetic planks made to simulate wood laid over joists or beams. The planks are laid with a small space between them, so rainwater does not collect on the deck. The same construction methods are used for decks and porches as for other parts of the house. The parts of deck construction that require special attention or that were not covered earlier in the text are discussed here. Planters. Planters are sometimes included in the construction of retaining walls or attached to the building. In these cases, the information needed to build the planter is included with the information for the building or retaining wall. The planter is built right along with the house or retaining wall. If a planter that is separate from other construction is included, it is usually shown with dimensions on the site plan. A special section may be included with the details and sections to show how the planter is constructed. The planter should be lined with a waterproof membrane, such as polyethylene, common plastic sheeting. This keeps the acids and salts in the soil from seeping through the planter and staining it. The planter should also include some way for water to escape. This can be through the bottom or through weep holes. Weep holes are openings just above ground level. In cold climates, the planter may be lined with compressible plastic foam. This allows the earth in the planter to expand as it freezes, without cracking the planter. If the planter is to have landscape lighting, automatic watering, and so on, additional waterproofing may be required where these utilities penetrate the waterproof membrane. Paved areas. Paved areas on housing sites are drives, walks, and patios. Drives and walks are usually described most fully in the specifications for the project. However, the site plan includes dimensions and necessary grading information for paved areas, as shown in this figure. These dimensions are usually quite straightforward and easy to understand. Paved areas can be either impervious, water will not pass through, or pervious, water passes through to the earth below. For small areas such as walkways, the choice of pervious or impervious is not significant, but for large areas this can be an important design question. If half-inch of rain falls on a paved area that is 100 feet by 20 feet, that is over 83 cubic feet or 617 gallons of water. If that much water drains at one point, it can do considerable damage to the landscape in that area. If impervious pavement, such as asphalt or concrete, is to be used, provisions should be made for groundwater runoff. Patios are similar to drives and walks in that they are flat areas of paving with easy-to-follow dimensions. They may differ from drives and walks by having different paving materials, such as slate, brick, and flagstone, for example. Patios may also be made of a concrete slab with different surface material. Plantings. Plantings include three types: grass or lawns, shrubs, and trees. On some projects, such items are planted by the owner. When the builder/contractor does the landscaping, the trees and shrubs are planted first, then the lawns are planted. Some or all of the trees included in the landscape design may have been left when the site was cleared. Any new trees to be planted are shown with a symbol and an identifying note, as shown in this figure. There is no widely accepted standard for the symbols used to represent trees and shrubs. Most architects and drafters use symbols that represent deciduous, leaf-shedding trees, coniferous, evergreen trees, palms, and low shrubs. The trees and shrubs may also be listed in a schedule of plantings. Grass is planted by seeding or sodding. Although a note on the site plan may indicate seeded or sodded areas, more detailed information is usually given on the schedule of plantings or in the specification. The landscaping should be planned at the beginning, along with the rest of the home. Grading should be done to ensure that storm runoff does not damage the plantings. The area should be surveyed for invasive species. If they exist, they should be removed before any landscaping begins, and certainly none should be introduced with the landscaping. Grading and planting should not harm the roots of any trees intended to remain on the site. In arid regions, design landscaping that requires little or no watering.